Welcome to the 8th of the Rescale Solutions live webinar series featuring hands-on demonstrations of the top science and engineering applications on Rescale. My name is Jolie Hales and I will be your moderator today. Today's focus is on how to accelerate crash analysis on Rescale by way of Ansys LS-DYNA. We also wanted to make you aware that the next webinar in this series will take place on September 23rd, and that will demonstrate how to perform operational weather forecasting using Rescale. So if you know anybody who might be interested in that subject, please feel free to share that information with them. You can find registration for any of our webinars on rescale.com or on any of our social channels as well. And you can find many of our past webinars recorded and posted on the Rescale YouTube channel. So feel free to subscribe there, take a look at our library of videos. And without further ado, let's go ahead and move into our presentations. So we have two presenters lined up for today. First is our guest presenter, Siddharth Shah, who is a principal product manager at Ansys. And a little bit about him, he is passionate about innovation and simulation that can help people solve tough engineering problems to design better products. He has spent the last 20 years at Ansys in various roles, including technical support, pre-sales, and product management. And most recently, he's working to expand the footprint of LS-DYNA in the CAE space since the recent acquisition of LSTC. After work, he can be found heading west to spend some time on the beaches of Orange County, California, as the harsh memories of winters in Pittsburgh and Detroit fade away. I was excited to learn that Siddharth and I are basically neighbors, so maybe we'll run into each other on an Orange County beach one of these weekends, considering it's one of the only places we can really go around here that isn't shut down. 6 feet apart, of course. There he is, hello. And our concluding presenter will be Nitin Jacob. And Nitin works as a customer success engineer at Rescale, based out of Detroit, Michigan. So he still has those cold winters, unfortunately. He is responsible for ensuring Rescale customers have a positive and successful adoption of the Rescale platform as they embark on their cloud HPC journey. And with a master's in mechanical engineering from Arizona State University, that's where my brother went. Nitin had 5 years of experience in the CAE industry, supporting engineers and scientists within the automotive, medical device, and manufacturing sectors. His interests outside of work include photography, playing table tennis, soccer, and kayaking. How fun is that? At this time, I will go ahead and turn the time over to Siddharth to take over, and let me give you some screen share opportunities, and then after that, we'll talk more with Nitin.
Well, thank you everyone for taking a valuable time from your day to join us. My name is Siddharth Shah, as Jolie introduced. Right after I'm done with this, I'm heading to the beach now, just joking. Today, I'm going to talk to you about Ansys LS-DYNA and give you a very brief tour of where we are in simulation with crash analysis. But before I do that, a brief introduction to some of you who may not know about Ansys. Ansys Inc., we are the world's largest engineering simulation software company. Engineering simulation, that's all we do. We are focused, leading product technologies in different areas, including crash. We are most trusted. 97 out of the top Fortune 100 industrials are our customers, more than 45,000 customers worldwide, consistently outperforming the market size. And this helps, a lot of it is thanks to you as customers or future customers. But we are a committed, driven company that one can partner with. And very happy and thank you to Rescale for giving me this opportunity to talk about Ansys today. A little bit about LSTC, again, one of the legends of CAE. It's very fortunate to see that the two legends in CAE, John Swanson, who started Ansys, and John Hallquist, now joining forces here. Of course, John Hallquist started the company LS-DYNA in 1987 to commercialize the public domain code DYNA 3D, which was developed at LLNL. And very happy to have LS-DYNA as part of the Ansys family. And what an amazing technology that has been built by John with LS-DYNA. Of course, the primary purpose of LS-DYNA has been explicit calculations, explicit simulation, short duration events, right? In addition, the scope of this technology has been expanded into many areas, into multi-physics. And in order to simulate crash, a lot of common tools and technologies need to be developed, which we have. And these has been made available to customers. So very excited to talk about some of this in a little bit, but to simply put, LS-DYNA is a strongly coupled, scalable multiphysics solver. And Nathan will talk about scalability and performance later on. If you look at the car crash simulation industry, this is around the time when, back in 1988, when the first crash simulation was started. It started with 25,000 elements, right? Imagine the journey we have made since then, and the incredible amount of details we have added over time. And so much so that now simulation is used as a way to validate crash and certify cars for crash and occupant safety, right? It's an incredible journey where, again, we're looking at 2006, about a 1.8 million element model. But what's happening today? Again, aggressive timelines. We're looking at features which have uniform mesh. There is more and more deformability in parts and in connections. More features are added like airbags, seat belts, dummies. Typical model sizes in the range of 10 to 15 million elements. Looking at material failure, joint failure, different complex contacts required. And oftentimes the computing based on the duration of the crash event is from 4 to 20 hours per simulation. That's the goal, that's the target. And on average, we see about 200 plus CPUs used per simulation. Of course, companies are looking at MPP. For those of you who don't know, there is a hybrid version of LS-DYNA, take furthermore advantage of scalability across large compute resources. And of course, here today, we're gathered here to learn more about cloud with Rescale, right? Again, the goal with crash simulation is to certify, is to ensure safety, and these include whiplash, pedestrian, rollover, etc. If you look at Dyna, we have an industry-leading HPC scalability, talking about MPP and hybrid. In certain class of problems, we have demonstrated that we get very good performance up to 2,000 to 4,000 cores, especially when you take advantage of the MPP hybrid solver. And the numbers that you see in this chart here show about a 60% performance improvement or speed up with our MPP hybrid. And this is state-of-the-art HPC scalability that we have been building over time. If you haven't tried it, please give it a try. Of course, LS-DYNA supports a wide array of MPI and OS platforms. Both single and double precisions are available. Just some recommendations on what we see in terms of crash and safety for those of you who may or may not be familiar. Typically, you use the solid elements to model radiators, bumpers, dummy seat cushion, tire discs, engine blocks, and transmission. We use a type 6 hourglass for solid elements. If you have a foam-like material, you use a formulation 0, we recommend, formulation 2 for rubber, and for the rest application, you use formulation 1. If you look at the shell elements, which would form bulk of the car structures, for most of the parts, we recommend a formulation 16 with hourglass type 8. And if you have membrane elements, things which are really, really thin, like an airbag or a seat belt, we recommend a formulation 9 for the shell elements. In addition, newer and newer technologies to get more and more accurate, we are also looking at application of thick shells. These are very good for composites materials. This could be an oil pan, or this could be other areas where somebody might use a composite section to dampen and reduce noise in cars. In those situations, thick shells are likely to be more accurate when you use a 4-noded shells, where the thickness to the radius of curvature exceeds 0.1, right? And with these thick shells, we recommend formulation 5 or 7. Some of the popular models, material models for crash and safety. Again, you have MAT piecewise linear plasticity, which is MAT 24. Again, we recommend MAT 181 for rubber. There is the advantage is there is no parameter fitting required. You perform the experiment and you directly input the stress strain curve data. Again, this could include adhesive or it could be head impactor skin material. We also developed MAT 187 to capture the characteristics of thermoplastics. Again, the advantage here is you can provide different yielding criteria for tension and compression, whether it's incompressible or in compression only or not in tension. Again, we have also built a tool called the material selector in case you have a question or you're experimenting with a new material. You can go to lsdc.com/dynamat, and there is a nice material selector. You can search through different applications and which materials to use. It's a fantastic option. The biggest next challenge with simulating a full car crash is contact. So many parts interacting with each other, connections. And as a result, over the years, we have built almost 35 different contact algorithms and options. Two ways to distinguish between these options is one is a method for searching of penetration and other is to remove penetration. This is an easy way to think about how to define contact options. We have a node to segment method. This is often used by automatic contact with soft option equal to 0 or 1. Then we have the segment-based approach, which I see most people use this, and it's very popular with soft equal to 2. It's a pinball method approach. So the search happens, when the contacting nodes are in the neighborhood of each other, and this makes it more efficient. We also have the option for mortar contact that you could use for implicit calculations where perhaps it's for dummy positioning or some other application or pre-stressing. We recommend that you use the mortar contact for implicit. Further exploring the contact options, oftentimes if you want to model sudden transition in spot welds or bonding, etc., of course the tight contact is available. And the other more popular contact option is the penalty contact. Soft Zero that was developed a while back, which was based on the master stiffness. The next generation of that penalty contact was soft equal to 1, where you have the option, where you have a situation where you have a soft component coming in contact with a hard component. This allows for better stability. And more recently, we've developed the soft equal to 2, which is very popular. And again, this is a dynamically adjust the penalty of the contact. Further into popular connections use, we obviously have options for deformable spot welds, whether you represent it as a beam or represent it as a solid. We do have options for detachable fasteners. Again, you can use them as solid or beam where you want to want the bolt joint or a connection to fail. We do have the option for initial stress of preloading the bolts numerically, and that's one picture that is being shown on the second picture on the right. Further, I'm seeing a lot of customers using non-detachable fasteners like adhesive, and we have developed a whole family of material loss to model adhesives. Again, this can be represented with element formulation 19, or with volume elements, or element formulation 20 to use shell elements. So this is a very fantastic technology. In addition to simulating the cars, you need to replicate the safety tests. You need barriers, you need dummies, you need tire models. And we have developed quite a few calibrated human dummy models, barrier models, and tire models. Some of these have been developed with customers like yourself. These are calibrated and validated so that you can incorporate and include them directly into your model. If you need access to these models, please reach out to our technical support staff, and we will be able to help you with these. Of course, as safety becomes more and more sophisticated, so is the need to model different kinds of seatbelt behavior. And how the retractor works, the pretensioner works, etc. And we have several options in that space as well. In addition, we also have airbag modeling capability, all included with the solver, where you can actually fold the airbag as it was manufactured, where we can simulate the folding behavior as well, or the manufacturing behavior. And then you can have the folded airbag model and deploy it into your crash model, and then trigger the event where the airbag is deployed. And even with airbags, we have some innovations made where we can control the performance, we can control the behavior of the airbag with regards to domain decomposition. Moving on to beyond crash analysis. So there's a lot more to LS-DYNA than just crash, and the purpose of these next few slides is to give a highlight of where else LS-DYNA is being used. Recent applications in the area of truck water weighting simulation using our next generation SPH technology. A lot of work is being done in the area of battery and battery abuse, battery impact calculations. What were to happen if an impact takes place that results in an internal shock? This requires complex contact, complex mechanics, complex electromagnetics, electrochemistry, all working together to provide the answer. In addition to water weighting simulation, also hydroplaning with flexible tires, this technology is also available. Another neat, interesting application I've seen recently is to assess fuel tank integrity. Will the fuel tank survive a crash event? What is the likelihood of a leak? How good is my seal? How good is my containment system? That's another application we have seen recent times. Another recent application is the coupling of discrete element method technology inside of LS-DYNA to take the car crash model, take the exact same model. You hide the parts that are not relevant, which are inside the car, because in this particular case, you're simulating what's happening outside. And we can couple DEM with ICFD to simulate mud deposition or snow deposition. And perhaps there is a rain sensing sensor or some other pedestrian safety sensor. And what would be the impact of the sensor in terms of sensor placement, sensor orientation, et cetera, that can be studied very quickly. If you look at manufacturing capabilities, we have ability to simulate forming and metal stamping with LS-DYNA. It is the industry standard in terms of accuracy and performance. And we've looked at different techniques, and here is an example of you have a hot forming where the sheet is heated and then it's formed and then it's lanced and where it's split over here in a two-step operation. Another application is, again, a complex roller hemming operation. It's kind of incredibly hard to do this. And you can see here, we have the ability to simulate that. Also, options for assembling of components of where different kind of components of a car are assembled. These are the things that we can include with our capabilities. Another neat and interesting application we have seen in recent times, unfortunately, I'm not able to show you the animation, is in the area of painting and e-coating. Again, we use our particle methods, meshless particle methods, to simulate the behavior of paint deposition and look at paint accumulation and e-coating behavior in a realistic time frame, and to solve a very tough problem in a realistic time frame. Another recent application or unique is the simulation of adhesive. As we talked about, adhesives are used oftentimes to join components in addition instead of spot weld in some cases. And companies are looking at solutions like dry adhesives, wet adhesives, which ones to use, how much should be the volume, what should be the pattern. And we have the ability to simulate adhesive hemming with LS-DYNA and particle methods. In addition to automotive, I just wanted to give a very brief introduction to LS-DYNA in other industries. We did talk about automotive, but LS-DYNA is widely used in aerospace, manufacturing, consumer goods, civil engineering, electronics, high techs, defense, and very neat applications with biomedical. Just a few animations to talk about different applications to describe what LS-DYNA can do. And keep us safe, especially for those who remember flying, that we used to do that. That was a thing. fan blade out, and what would happen? Could we have a sufficient containment system if there's a fan blade out event, or if there's a bird strike event? Another application area is for space shuttle water landing, and this was another technology that was used to demonstrate what LS-DYNA can do. In the area of defense, we've developed a new technology to handle porous membranes and porous behavior. To demonstrate this example, it's a parachute attached to a capsule that is being dropped from space. And this is a complex CFD multi-physics problem that we can solve. Look at ballistic impact. Another interesting applications, very cool technology in the area of braiding and manufacturing, and companies were looking at use of different fabrics for different components in cars, different manufacturing techniques, shrink wrap techniques for different applications or different manufacturing applications. LS-DYNA has the ability to handle large deformation, large strains in an efficient manner. Another introduction to hot forming and lancing that work that was done, and spin forming application that we did. Finally, looking at biomedical, this is one of my favorite projects. Is we want to be able to simulate a human heart, and this requires complex physics, just electrophysiology, mechanics, flow behavior, and how all of this is coupled together. And oh, by the way, let's put in a tiny pacemaker inside and see whether it behaves, whether it gets attached or it detaches based on the pulse that the human heart experiences. Very complex capabilities, all solved inside LS-DYNA solver. There are a few animations talking about surgical process simulation and syringe drop test. And finally, with electronics, looking at drop and devices and what the behavior is when these are drops. I hope this doesn't happen to any one of us, right? And you look at consumer goods, we look at packaging applications, you look at helmet design. Nobody wants a package to be delivered like this and it's poor and the contents get damaged. So look at designing this, reinforcing these corners and what would happen, different options. And same is the case with bottle design and packaging and top load simulation, where LS-DYNA is used. And finally, we look at civil engineering applications. And there are two ways to simulate civil structures. One is to do in the linear dynamics domain, and the other is in the transient domain. And some applications which are really, really large, like in the case of this mock-up nuclear structure, and we look at the behavior when there is a seismic event. We have been able to do this with LS-DYNA, and look at what will happen when a large earthquake event will happen to assess the integrity of the structures. With that, for more information, please reach out to Ansys customer support. There are several LS-DYNA resources available online. Here are a few links that are listed here. And if you have a need to look at the different LS-DYNA models, please reach out to us. In summary, LS-DYNA is the most powerful explicit multiphysics solver. It's used for several different simulations: automotive, crash, sports equipment, biomedical drop, etc. That's all I have, Jolie. Over to you.
Perfect. Thank you so much. That's some pretty cool stuff, Siddharth. It's awesome. Thank you. We do have some questions popping in here. I'm going to hang on to those questions to the end, but if you don't mind sticking around with us, Siddharth, then I'm sure that some of these questions could be answered really well by you.
I'll be around.
Okay, perfect. Thank you. All right, I'm going to go ahead and turn over control to Nitin Jacob.
Perfect. Thank you, Jolie. Thank you, Siddharth, as well, for that very interesting presentation. Personally, it was nice to see you guys have now simulations on snow depositions for those of us up here still in the Northeast with those harsh winters. So very interesting information. So thank you again for all those of you who have joined for the second half of this webinar. We're going to focus more on the Rescale platform and specifically go over a demo of running LS-DYNA crash simulations on Rescale. Again, if you have any questions during the presentation, please feel free to type it in the chat window as well. So let's start off by taking a look at how the Rescale web platform really functions. At a high level, the goal behind the Rescale platform is really to ensure that the end users, which are typically engineers, scientists, R&D researchers, they're only spending their valuable time really solving their simulations, right? Focusing on improving their products and not really worrying about everything that goes around in the background. Everything that goes around, all the complexities that goes into implementing an HPC cluster. So how is Rescale actually tackling this issue and making it easier for the end users? Today, we have partnered with close to all the major ISVs, all the major software vendors, such as Ansys, to onboard close to 500 plus softwares, as well as over 2,000 versions, which are already tuned to run out of the box on cloud resources. So whether that be running your LS-DYNA simulations, full vehicle simulations, seatbelt simulations, airbags, all those different applications that Siddharth mentioned, all the tools required are already onboarded for you guys to get up and running. In the backend, we also partner with all the famous cloud providers, so all the famous names that you already hear, such as AWS, Azure, Google Cloud, IBM. We have some bare metal offerings coming up from Oracle as well. So all your jobs are already, all the softwares are already, onboarded and tuned to run on all these cloud providers and all the different architecture that they provide. Finally, Rescale additionally also takes over the complexity of and the responsibility of implementing the entire stack of enterprise deployment tools, right? All the tools, all the middleware, all the other aspects that go into setting up such a HPC environment. So the end result of this, so what's really the end result? The end result is that the end users, which I mentioned previously, scientists, engineers, they're abstracted away from all these complexities. All they have is the web platform, and they follow a streamlined workflow of uploading input files, choosing which software they want to run the job on, and what hardware they want to submit the job on. So that's all that they need to worry about, and everything else, the heavy lifting, is taken over completely by Rescale. So now let's actually take a small deeper look at what I meant by this entire HPC stack, and where Rescale is really playing this role. So in this slide here, what you're seeing is all the tools, services, components, everything that's required typically by an HPC admin to set up and manage an HPC cluster. So this entails everything from, installing and running different applications, application support, all the schedulers, tools, middleware, operating system, implementing them, managing them, also the infrastructure for their clusters, the physical housing. So all of this that you see here, each of these boxes have a cost associated to it, and that's completely burdened by the HPC admin or the customer when they're doing it by themselves. So where does Rescale really fit in, and how do we actually take away the burden? So if you see this slide here, all that you see in the blue boxes, all the boxes that you see shaded in blue are actually managed by Rescale. And all the light blue boxes that you see here, everything from physical housing to some components of the network and infrastructure, is taken over completely by the cloud providers as well. So we take care of all the orchestration. They take care of all the the hardware requirements, and really what that means is the end users are just spending their time on running their simulations, getting their results faster, pushing their products faster to market and beating the competition. So that gives you a good idea of what components we are actually taking over and how we are making it easy for not only the engineers but also admins and HPC admins to be able to use Rescale as the dedicated solution for cloud computing. In the next slide, let's actually take a quick look at what the typical on-prem hardware refresh cycle looks like. So this is a typical on-prem hardware HPC cluster, and let's take a look at how it has progressed over the past 7 years. So here you can see that there's a lot of different architectures already on board. So we have everything from Ivy Bridge, Haswell, Broadwell, Skylake, Cascade Lake that was introduced over that time period. But if you look into the HPC cluster, that the on-premise HPC cluster, the refresh rate is not that fast, right? And there's a reason behind that, because they've spent a lot of money putting all these resources on the floor, and refreshing them at a very fast pace completely is not financially a right option. So you can see here that even in 2019, when Cascade Lake has been introduced, there's a lot of usage of older architectures such as Haswell and Broadwell within the on-prem cluster. Now, let's take a look at how this changes when you switch to running simulations on Rescale. So here you can see that at any point of time when the cloud providers are making the latest and greatest architecture available, you guys have immediate access to it. There's no downtime associated with setting up, or ordering different parts to set up a whole HPC cluster. With a turnkey solution, you get access to all the latest and greatest. And you're also not boxed in on a specific demand. You're able to also, burst according to your demands for your different projects that you want to run. So you're only running those simulations and on those hardwares that you really need, and only paying for those time that you actually use those clusters for. Finally, before we jump into the demo itself, just touch base on another point, another value proposition of moving to Rescale. Typically on the on-premise HPC cluster, there's a lot of resource constraints to running your job. So typically there will be either a limited number of hardware resources that you can run a job on, or there will be different policies such as, X number of users can submit X number of jobs at any point of time, or if it's also, specific groups of users can only submit specific number of jobs. So your jobs tend to get queued, and there's a wait time associated with it. There's engineering time lost as well. So there's a dollar amount that's also lost with all the wait time introduced by this queuing on-prem. Now, moving onto the cloud, you get access to unlimited hardware resources. So you don't have to worry about queuing up your jobs today. You're able to vertically scale and submit jobs as and when you need to. And you don't have to sit in a queue waiting for those jobs to actually start running. So this provides a direct dollar associated with both time savings as well as faster time to simulation results. Another advantage is that on Rescale, like I mentioned, you have the multi-cloud options. We have partnered with all the different cloud providers, and all their architecture is already on Rescale whenever they release it. So you can get access to compute optimized resources. And what that means is, diving back to what Siddharth mentioned, if you want to run like your explicit simulations on Rescale, you can use those core types that have high clock speed, high interconnect speeds. While if you want to run those implicit jobs, which are more memory bound, then you can completely use a different set of resources. You can use a set of completely different resources that have higher memory in that architecture. So the end result is you're able to get all your results faster and a shorter turnaround time for you to push your results onto to post-process your results as well. So going through all that slides, let's actually jump into the more interesting part. We're going to focus on running a DYNA job. And here we are assuming that all the pre-processing has already been completed by the end user on-prem. And they're going to upload the input deck and run the Ansys LS-DYNA job on Rescale. And we're also going to take a look at how to use desktops to post-process those results. For this demonstration, we're going to use the a standard benchmark from LSTC for two minivans actually colliding head-on with each other. So with that, I'll actually move on to the Rescale platform. So here I've logged into my Rescale web platform. So like I mentioned, it's a web portal. So all the end users do is log into their account using any browser, and they're ready to start submitting jobs right away. So the first time you log into Rescale, you have this welcome to Rescale message with a couple of different tutorials that you can use to get started. We have this ribbon on the top, which provides you all the navigation aspects. Like it will help you navigate through all the different aspects on Rescale. So it's a very clean UI, and you can get started as soon as you have an account. So let's take a look at creating a new job from scratch. So let's hit the new job button. So once you have created the new job, you see that same interface that I showcased during my presentation. And these are the steps that we're going to go through: the inputs, the softwares, and the hardwares selections to submit this job here. So first step, let's actually give the job a name. So I'm just going to give it a very simple name. Webinar, that's DYNA. As you can see, my spelling skills are not that great. Okay. So once we have given the job a name, we can go through these steps now. Feel free to use this GUI-based approach or the top-to-bottom approach here. It's exactly the same. So for the input selection, we have a couple of options. You can add from cloud storage. You can upload from your own local computer. Or if you have a high-performance storage attached to your account, you can add from that as well. So let's actually just use cloud storage. So I previously already uploaded all the input files here. So I'm going to browse from cloud storage. I have a folder here with all the input files. So you can see I have 3K files in here. I'm going to select all of that and add it to this input section here. So you can see that all the files have already been uploaded. Now, typically, if your simulation has a lot of include files and a master file, then you can just zip all of them into one compressed file and upload it directly into Rescale. It'll help with your upload speeds, and automatically all the zipped files are going to be uncompressed once they hit the cluster. So you don't need to manually uncompress any of them. So if you have a lot of K files, just zip them up into a single K file and upload them onto Rescale. Here I have two K files with geometry information for the two minivans, and I have the master K file that's going to be used to execute the job. So if you have like a ASCII readable file, you can actually edit that within Rescale itself. So if you want to make like simple changes to your control variables, you can do that within Rescale. You don't have to download it back and like do it through the pre-processing step. So you have that option as well. So for this, I have completed the upload part of the files, input files. I'm going to move to the software selection part. And here is where you get access to all the different, so I mentioned we have close to 500 plus softwares. You can see all the different Ansys tools here as well. So you'll get a subset of the tools that your admins have made available to you. So probably if you're only a crash user, you'll get access to Ansys LS-DYNA to run your jobs. So here I'm just going to search for Dyna. I'm going to choose the LSTC version of LS-DYNA here. So like I mentioned previously, we have all multiple versions already onboarded on the platform. So you can see we have the latest and greatest from version 12 all the way to legacy versions in case you have clients which require those different versions for your work. You also have the ability to directly onboard custom versions and revisions using by inputting the binaries onto as input files as well within Rescale. So for this demonstration, let's use the latest and greatest here. So you'll also see the set of input files associated that we had gone through previously and uploaded. In the command section, all you need to do is actually highlight the master K file as the input file. So here I've highlighted that. I've added that into my command. And the platform will actually change that font to green if it can recognize it within the input text. So it's kind of like a sanity check to make sure you have the right command in here. But that's all you need to do from a command perspective. You just need to input the master K file as the input file. If you want to run it on double precision, you can change the precision mode to double as well. But we're going to leave it as default here. So once you've selected the version and the command, the next step is obviously choose licensing. So we have a couple of options here. So LSTC Ansys does make available the option for on-demand licensing on the platform. So that means now you have not only unlimited hardware resources, but you have on-demand access to licensing as well. So you can scale without any limitations on the software end or the hardware end. There's a straightforward explanation on how the costs associated with on-demand licensing are. And also, if you have access to your own purchased Ansys LS-DYNA license that you're hosting on-prem, then we can directly connect to that license as well. We can connect with the port information as well as host name and use that to run your jobs on Rescale. For this example, we're going to stick to the default on-demand license option. So we've completed the software section. So we selected the software, we selected the version, we made sure the run command is right, and we have selected the license option. Now this takes us to the last step, which is the hardware settings page. This is the most interesting page where you get access to all the different, hardware architectures that's made available by those cloud providers I mentioned previously. So here you can see that by default, platform has also intelligently, suggested the best core type that will work for LS-DYNA workloads. So you can directly, if you want to choose just the recommended option, you have that option to go as well. But here you'll see a lot of different categories. So we have categorized the different core type options on the platform for easier access as well. So if you want to run like a general purpose core type, you have those options, and you have full visibility into what the architecture is of that core type. What chipset it's using, what the memory per core is, what the interconnect speeds are, what the storage is coming with it, and the price as well. So we have it categorized by general purpose. Like I mentioned, if you want to run those explicit jobs and you're running it on a lot of nodes, you want those kind of core types that have high interconnect. So you can choose like the Carbon that's recommended here with very high InfiniBand connections for the interconnects. Or if you want to run those the implicit jobs which are more memory dependent, then you can choose these core options which you can see higher memory per core on the platform as well. And we have high clock speed as well as high disk. And if you're running anything on GPUs, we have some options as well. And do keep in mind that you will not be presented with all this drastic list of options and be forced to make a decision. You're confused what option to choose. The general approach is that we do an exercise of benchmarking with you for your own models, and we will always suggest a couple of core types which are best suited for your workflows. So like I mentioned previously in my slides, we make sure we're using the best the optimized architecture for your different simulations. So you'll only have a subset of core types to choose from to submit your jobs. So for this example, I'm just going to use, it's a smaller job, so I don't need those higher processing power. I'm just going to choose a general purpose option here with Emerald. Once you have chosen the core type, you can set the number of cores you want to run, or you can set the number of nodes as well on the platform. So you really don't have any limits, depending on the size of the model, you can scale up and run it on as many cores as you want to on Rescale. You also get complete information on the architecture that you selected, right? So here I've selected 8 nodes, total of 288 cores with 36 cores per node and so forth. So for this example, I'm just going to run it on one node of Emerald. And once you've selected the hardware, the only last step you can do is check for inputting a right wall time. So you want to make sure that your job doesn't, your cluster doesn't get shut down before your job completes. So make sure you have a realistic wall time in there as well. Now, once you've gone, so we have completed inputs, choosing software, hardware. At this stage, we're actually ready to submit the job. There's an optional step. There's an optional post-processing step. So if you want to upload some, post-processing scripts, you can do that at this stage, and it will be executed after the simulation is completed on the cluster itself. It's an optional process, and I'm going to leave that in this demo. So now you're ready to submit the job. You have a couple of options. You can save or submit, and it gives you a quick high-level overview of what you have selected for this job. So we can go ahead and submit this job. So you can see that once you have submitted the job, it will populate the status page, and here is where you can monitor, how your cluster is getting started and so forth. So this will take a couple of minutes to get launched. So for the interest of saving time, I'm going to move on to a job that I launched before this webinar. So we have one of these running jobs here, the same job. So here you can see that the cluster actually took around 3 minutes. It took around 3 minutes for the platform to start up the cluster, and the job has been running for around 3 hours or so. So now I want to highlight some of the aspects of how you can interact with the job from within the Rescale interface or the platform itself. So starting off with the live tailing section, here is where you get access to all the different files that are being created or generated while the simulation is running on the cluster. So you can search for all the different files. For example, if you want to look at the D3 plots that are being generated, you can select them and download them from directly here. But more importantly, if you have log files, so for example, if you want to tail the LS-DYNA log file to see how the simulation has been progressing, you can do that from within the Rescale interface itself by selecting that log file. So those are some options for you to interact with the files that are being generated, just to check, quickly if your jobs are progressing as expected. That's the live tailing menu. Going on, we also have an interesting option here, which is the SSH session. So we have built an in-platform SSH session, so you don't have to actually set up keys and set up the whole key pair on the platform as well as on your local system. You can directly SSH into the cluster by hitting the server IP here. It's going to open up an SSH session, and if you're a Linux savvy user, you can do all your Linux shell scripting directly here in this SSH window. So for example, you can go to the shared directory where you can see all the files that have been created while the simulation is progressing. And if you want to do some file management directly using Linux, you can do that right here as well. Or you can look at how your simulation is progressing. Yeah, so having said that, so that brings me towards the next point that I wanted to go over. So we looked at live tailing as well as SSH in-browser SSH. Now let's move on to looking at how a completed job looks like and how we can manage those results, or how we can do some post-processing within the Rescale interface. So going back to the jobs menu, I have this job that was already completed. So you can see that now it has completed in 2 hours. And now if I go to the results menu, here's where I get all those files that have been generated by the solver within the cluster. So all these files have been created. It has been moved back to your Rescale storage. And here is where you have access to them. So you have a couple of options. You can either download a subset of files to your local system if you want to post-process it. So for example, typically users will want to download their D3 plots. You can select the subset of D3 plots and just download those selected files to your local system, or you can search for the bin outs and so forth. And finally, if you just want to download all the job results directly onto your local system, you can just hit the download job, which will zip up all the results and download it onto your local computer. Having said that, we also have the options to do post-processing within Rescale itself. So we have virtual desktops that I want to touch base on quickly. So if you do not want to move all this data back and forth, you can post-process within the interface as well. So let's take a look at how you would do that. So to post-process, we go to the desktops menu. So here you can see it's very similar to the setup is very similar to the batch workflow, but you're going to be launching virtual desktops here. So you can see here I have a couple of desktops that have already been launched. But let's go through the quick procedure of launching a desktop from scratch. So like I said, the approach is very straightforward. You hit the new custom desktop, give your desktop a name. Again, you'll see a lot of different desktop options here. So we have Windows desktops, we have Linux desktops, and we also have some desktops with GPUs. Intrinsic post-processing, you can do that. Intensive post-processing, you can do that within the Rescale desktops as well. So having said that, so here you can see the list of softwares that you can attach to this desktop as well. So we'll just search for LS Prepost that you can use as the post-processing software. And here is where you can attach all those jobs, even executing jobs that you want to attach or completed jobs that you want to attach to this desktop for post-processing. Once you have done that, you can hit launch and the desktop will go over the similar checks of that you saw with the batch workflows and launch that desktop session. So again, to save time, I did launch a couple of desktops previously that we can connect to. So this is one of those desktops that I connected to. So we also give the option for connecting in browser. So you don't even need to like download any files and set up Windows RDP. So you can connect it directly through your existing browser as well. So here you can see I've launched that desktop session. On the desktop of this VDI, you will see a folder called Attached Jobs. So here is where you'll get access to all those jobs that you previously attached while setting up those desktops. So you can see here under Attached Jobs, this is the job that I attached. We have an input folder with all the input files as well as the output folder. So you can see here all the D3 plots that were generated while that simulation was completed is attached to this desktop session. So then you can launch like an LS Prepost session that I've launched here, and you can run your, you can just navigate to the D3 plots or the bin outs, whatever results files you want to post process, and you can post process that directly on the Rescale desktop as well. So that covers how to use Rescale desktops and how to do some post processing directly of your results on Rescale without having to transfer all your files. With that, it brings me to the conclusion of most of what I wanted to present for today's webinar from the Rescale standpoint as well. It looks like we have 10 more minutes. Jolie, I want to turn it back to you. If there are any questions, we can take it at this point as well.
Yeah, it looks like we do have a few questions coming in. We'll start with one from Tom. Tom asks, can we interact with the running model with a remote visualization PC while it's running?
Definitely. So that's a really good question. So going back to the desktop option, so let's actually take a look at a job that's currently running. So we have this job that's running. So here, if you go to the running jobs page, you can visualize the results by directly choosing the visualize option. So here you'll see a visualize option, a visualize button. And what this really does is it is going to launch that same desktop that we saw previously, but it's already going to configure everything. It's going to attach the software LS Prepost. It's going to set a configuration for that hardware, and it's also going to attach that job directly. So when you hit launch for this job, it's going to pull up that desktop exactly similar to what you saw here. But instead of a completed job, you would see the folder for a running job, and it would be continuously updated with the running T3 plots, the bin outs, so you can post-process those results again while your job is running. So that's definitely possible on Rescale.
Great. Okay, a couple of questions here from Anoop. How do let's see, this is in context of the two examples shown. So the adhesive simulation and the pumping heart simulation from you, Siddharth. He says, how do the fluent mechanics, physics in LS-DYNA compare to the physics available in a CFD code like Fluent?
That's a good question. In the application where we were doing the pumping heart, where more than 3 physics are required to work in concurrent at the same time, and that's a unique application. So the fluid dynamics technology was developed, which was incompressible flow, and it was developed completely inside of the LS-DYNA solver. So Fluent, I would look at Fluent technology as a high fidelity capability, and it's really the state of the art and the best in the world. If you look at applications, for example, where it's tightly coupled required, where structure response is the source of what you're looking at, the LS-DYNA functionality is unique, and it takes care of a lot of mapping and transfer of files for the user, especially in the case of adhesive simulation, where we used a DEM approach. There are multiple approaches we could have taken, and the example that I showed, we use DEM, the discrete element method technology, to directly interact with the structure. So again, no one tool can solve all problems. I look at Ansys as this really giant toolbox, and we have all different kinds of tools to solve different kinds of problems. It's a good question.
Great. We have some follow-up questions from Tom as well. Says, can we interact with the running model with a remote visualization? Oh, wait, I already said that one. Just kidding, but there's more here. Can we specify what post processor beside, is it LSPRE? Oh, yeah, LS pre or post type review? And do we pay for LS-DYNA licensing through Rescale, or do we need to provide our own?
Yeah, those are both really good questions. So the first question on the visualization part, yes, you do have the option to add, your own choice of preprocessors. So for example, we have like HyperWorks, which is used by a lot of users. So we are definitely onboard a lot of post processors. So there's a lot of lists of post processors. But if there's a specific post processor that you're interested in using, we can onboard that as well and to make that available during the desktop sessions as well. For the second question with regards to the licensing, so if you're going the on-demand licensing route, so you would the way it would work is that you would pay per simulation, so the cost would go through Rescale. But if you were bringing your own existing license, then you would purchase the license from Ansys, and then once we have the licensing information, we can set up methods to connect your purchase license.
Great. Another question. This one's from Jeff. Can we submit scripts while a job is running?
To submit scripts while a job is running. So typically, when you create a job on Rescale, you do submit all the scripts as well as input files required when you're setting up the job. I will have to double check if there are any other approaches we can take there to submit scripts to a running job, but I'll get back to you on that question.
Great. Another one here says, is there any way to process the intermediate files, the D3 plot files, while the job is executing?
Yeah, this goes back to the previous question on processing the results while the job is running. So it'll be the same approach. So while the job is running, you would use the visualize option to set up the desktop, and the workflow would be exactly the same. You'd have access to the folder where the running folder of this job where all the files are being generated, and you'll be able to use your post processor within that VDI session to post process the DP plots or any other files that you have while the job is running. So it'll be the same approach. Yeah.
Okay, cool. That makes sense. This one is for Siddharth at Ansys. What is the latest version of the LS-DYNA solver?
Oh, that's a good question. And I saw that Nitin did indeed use the latest version. The latest version is version 12.0. We just launched version 12 back in July of this year. If you have any more questions, please reach out to me. Thank you.
It looks like we just
Yeah,
have one more. This question. Oh, go ahead. Sorry, I didn't mean to interrupt.
No, yeah. I was just mentioning, like Siddharth mentioned. So we do onboard all the latest versions as they're made available by Ansys. So we have it always up and available for the users.
Great. We've got one last question here, unless I see any more pop up in the next 60 seconds or so. This is from Aditi. Can I SSH directly into the cluster from my local machine to run some Linux shell commands, not using the in-browser SSH feature that you showed us?
Yes, definitely. So that's also an option today. So the way you would do that is you would set up a SSH key pair. So if you're using Windows, you'd use PuTTY, or if you're using like Linux, you can use SSH keygen. So the process would be you'd create a key pair and you would upload your public key onto the Rescale job settings menu. So here you have job settings under your user profile. And here you can see I have actually my public key already pasted in here. So once you have your public key pasted under your user profile settings and you access a running job, so for example, let's go to a running job here. Then all you need to actually do is copy this SSH command key here, and you can directly put that into your terminal. So if I launch a terminal window here, let me just do that here. And all you need to do is actually paste it in there, and you can get connected onto the cluster via your own terminal session. Yep. So definitely that's also possible on Rescale.
Great. It doesn't look like we have any additional questions. I appreciate both of you and your presentations. Very interesting stuff. And to everyone who joined us today, just another reminder that our next webinar is on September 23rd, and registration is on rescale.com or our social channels. And this recording will be made available via our YouTube channel as well. So feel free to take a look there. Thank you so much for joining us, and stay safe out there.